Alright, so the next thing that we're going to talk about are coordinate systems and how those work. You've got two basic coordinate systems, Cartesian, which are your xy coordinates, and polar with r's and thetas. These shouldn't be anything new, just like you learned in math class. We're just going to kind of review them. The first one is Cartesian, or rectangular coordinate system is another name used for that one. You've got three perpendicular axes, your x, y, and z, where all of those axes meet is called the origin, coordinates 0, 0, 0. For this class, we're only going to deal with 2D drafting, mostly until we get to the very, very end if we've got time. So in our case, we're just going to deal with x's and y's. Our z value is always going to be 0. So here's some, examples of what different coordinates might look like. Here's the 3D coordinates where you have your x, z, and y axes, and you might have a coordinate out here in space, and it has x, y, and z variables. In our class, we're just going to deal with the 2D Cartesian coordinate system, where our z is always equal to 0. So when we're talking about our x's and y's, this is how we're going to lay them out. X is to the right or left, and y's are up and down. So what I want you to do is follow this example. We're going to draw a line from point 0, 0, so the origin, to point 2, 3. So here's the steps that you're going to follow to make that happen. So from my command line, I'm going to type in L, enter for line. It doesn't matter if it's uppercase or lowercase, makes no difference. So L, enter. It asks me, always got to read your command line, specify first point. Well, my first point I said was going to be at 0, 0, that coordinate. So I typed in 0, 0. I'm going to push enter. You'll notice some things happen on your screen. I'm moving my mouse around, and you'll notice that I'm seeing a line, and one point in the lower left-hand corner of that line is kind of anchored down at the origin in the lower left-hand corner of my screen. Now it's asking me to specify next point. So the next point of my line, and I apologize, I am updating my Java right now, so get that off of there. Specify next point is going to be 2, 3, and then enter. So now you'll notice that you should have a line that comes from the origin, goes over 2, and up 3. So it's asking me again, specify next point. Well, I'm done drawing that line. I kind of want to get out of this command, so I'm just going to push the escape key. That canceled my line command, and now you'll see that I have a line in the lower left-hand corner of my screen that goes to the right 2 units and up 3 units from the origin to point 2, 3. So pretty simple. Should have something that has that kind of a slope to it. Okay, what I want you to do now is play around and see if you can draw these other lines from 0, 0 to maybe the point -3, 1, and from 0, 0 to the point -1.5, -2.5. Now whenever you draw these lines, you may not be able to see them very well. It's just a matter of how you're viewing that drawing window. I'm going to show you one other quick trick to help you be able to visualize and see things a little bit better. If you've got, push escape to empty out your command line. If you press Z for zoom, press Z and then enter. You can always do Z for zoom, and then the next thing that it asks for, you've got all of these commands down here, all, center, dynamic, extent, all of these different things. If you either click or type A for all, it's going to kind of zoom out and let you see things a little bit better. So if you want to move around on your screen, you can use your mouse and click your wheel down and pan, or you can also view your scroll bars over here to take a look at things. So there's my line from 0 to 2, 3. I'm going to go ahead and put in the other 2 lines. So now you'll see I've got those lines in there. Remember, anytime you need to undo something, if you screw up, you've got the undo key up here in the upper left in your quick access toolbar. Okay, you can always undo. You don't necessarily have to start from scratch. Or if you type something in incorrectly in that command line, just press escape, and that'll quit whatever it is that you were in the process of typing in, and let you go back and kind of try again. So hopefully you were able to do that. And again, that was the Cartesian system. Now the other system is the polar coordinate system, and this one is a little bit different, okay? You still have axes, you still have an origin, except for in this one, our coordinates are r's for the radial coordinate and thetas for the angular coordinate. So the radial coordinate is that shortest distance measured between the origin and the particular point. So kind of think about like a radius out to that point. And then the angle is between the radial coordinate and the x-axis. So to give you an idea of the polar coordinate system, ours is going to look something like this. If this is my point out here in space, the distance between that point and the origin is the r value, and then the theta or the angle is starting from the east. If we call this 0, and remember we're getting positive and are increasing our angular measurement as we go around, that would be our theta coordinate. So here's an example right here where this might be radius 1, this first red circle, this might be radius 2, this might be radius 3. So the point right in here, the coordinate for that might be 3, 60. Or a coordinate out here on this one might be 3, 210, where the first point is the r, and then the second point in your polar coordinate system is the theta. So let's try this and see what we get. We're going to draw a line from 0, 0 to this point, radius 3.5, theta 60. So I'm going to do L, enter. The first point is at the origin, so 0, 0, enter. See how it's kind of stuck right there? And we know that 360 should be in this area somewhere out here, okay? So I'm going to go, the radial coordinate was 3.5, so I'm going to type in 3.5. And notice this time, because it is a polar coordinate, I'm not going to use my comma. I'm going to use the less than symbol, or the shift comma, and then put in the angle. So that symbol that you see there, the less than symbol in AutoCAD, stands for angle. So now I can type in 3.5 less than 60. So that tells the computer that we're looking at an r of 3.5 and an angle theta of 60, and then enter. So you'll notice that that line is very close to the very first line that we drew when we were doing this particular assignment. So it should look something like that. So anytime that you're playing around in AutoCAD, you'll notice down in your status bar at the very bottom left of your screen that you see some coordinate values on there. So we know that this point right there should be really close to 2, 3. I can get my mouse close. It's not exact, but it kind of gives me an idea of where I'm at on the screen. You really never want to use, try to move your mouse until you get those values exact, because it's never really going to happen. But just kind of quick way to look and see where you're at as far as your coordinate system goes on your screen. So another thing that we can talk about is a thing called relative coordinates. So this one is a little bit different. Sometimes when we start with a line, we know the line's length and the angle, but we don't necessarily know its coordinates. So what we can do is use a thing called relative coordinates, and that's where CAD lets you take that last point that you just used, wherever it happens to be on the screen, and kind of make it a new temporary origin. So anytime that you use the ampersand or the @ symbol and you put that before a coordinate, it basically says, okay, I'm going to look at the last place that you were at, and I'm going to temporarily call that the origin. So to give you an example, we're going to come into our command line, and we're going to do L, enter. We're going to just click a point out there on the screen somewhere for our very first line. So I'm going to do L, enter. It's asking for the first point. I'm just going to click somewhere out here in space. Really doesn't matter exactly where my cursor is. I'm going to click. So now you can see that I have the first piece of that line selected. So now what I'm going to do is use relative coordinates and type in @4, 2. So let's think about what this is doing. The @ symbol says, okay, I'm going to take this point that you just clicked out here in space that I'm not exactly sure what the coordinates of that point are. I'm going to call that the temporary origin. Then I'm going to go 4 units to the right and 2 units up. So go ahead and click enter. And you'll notice that now you've got a line 4 units to the right and 2 units to the positive. So that's an example of using relative coordinates. Anytime you use that ampersand symbol, that's what's going to happen. So at this point in time, if I wanted to draw a line straight down and say, let's go down 2 units, what could I type? Well, I could use the @ symbol because I really am not sure where that last coordinate point was, and I want to come down 2 units. So left to right, I'm going to move 0. And then if I want to come down 2, that would be a -2 in the y direction. Enter. Now if I wanted to go back this way, do I know that distance? Not really, so I'm not even going to try because I'm not going to have to do any right triangle math today. Not in Drafting 1 class. Alright, so your homework assignment is found out there on eCampus, and you're going to follow instructions that are provided out there on that handout. But basically what you're going to do is you're going to start with that set-inch template that we already started out with, and you're going to end up with a file called relativecoordinate.dwg. Once you've got that file, you're going to go back into eCampus and upload it and send it to me that way, and that's your homework assignment, your very first one, creating a CAD file. That's all.